So this is the second and last video for proportional relationships and graphs. And your I can statement is to analyze a graph to determine if a relationship is proportional. All right, so here's a quick reminder. Remember that a proportional relationship follows this format where A, right here, is the constant of proportionality. But for something to be considered proportional, it's got to be y equals ax, where A would be a number, and y and x would be your output and input. Here's how to tell if something's proportional just by looking at something graph, like a line on a graph. If it passes through the origin and is a straight line, then it describes a proportional relationship. Remember, the origin is 0, 0. And so remember the XY graphing system. Here's my x's, my x numbers on the horizontal axis, and then my y's are that vertical axis, that up and down. So if I had to graph the point 2, 3, this tells me to go over to the right 2 and then go up 3 and make a point. Okay, so here's the first example. It says complete the table, graph the relationship, and then determine if the relationship is proportional. Justify your answer. An internet cafe charges a one-time $5 service fee and then $2 for every hour of use. Okay, so if we think about it, the rule would be y would have to be my output here, my total cost. X would be my input, the time in hours. It says my total cost then must be equal to $2 every hour, so 2 times the hours of X, and then plus a one-time $5 service fee. Okay, so at time 1 hour it cost me $7. That makes sense. 1 times 2 is 2 plus 5 is 7. But 2, if I plugged in 2 for this X, it would be 2 times 2, which is 4, plus 5 is 9. So I can write that here. Now I got to work backwards here. If y was 11 and that equaled 2x plus 5, the question is 2 times what number plus 5 is 11? Well, 2 times 3 would work because 2 times 3 is 6 and 6 plus 5 is 11. So x must be 3. Okay, good. That was easier than I thought it would be. And then we got one more. What happens when x is 4? Well, for this one, I'm going to actually plug it in and write it down. So y equals 2 times 4, because that's my x number, plus 5. 2 times 4 is 8, and 8 plus 5 is 13. Okay, great. So I completed the table. I did accomplish my first step here. And I want to be seeing those calculations for you to be getting from your inputs to your outputs and from your output to your input, depending on what value is missing. But now I got to graph all my points. So this is my time here in the horizontal axis. And I'm going to be asking you guys to create your own graphs on the worksheet after this video. And I'm going to ask you to try to remember to put your time on the x-axis, or always make sure your inputs always end up on the x-axis and your outputs end up on the y-axis here. All right, so the 0.17 should be graphed. So at 1 hour, it cost me $7, right about there, in between 6 and 8. At 2 hours, it cost $9, right there between the 8 and the 9. 3 hours, it cost $11, right there. And 4 hours cost $13. All right, so now I'm going to connect these with the line. Let's see here. I think this is the right one to select. And I think it'll be right about, oh, it's the wrong one. Let me pick my other arrow. Be this one. There we go. I want the arrow to be pointing in the right direction. So if I was to connect those with a line, it would be looking something like that. Well, slightly off at the beginning, but that's pretty close. All right, well, let me remind you back here that some qualifications for whether or not something's considered proportional just by looking at the graph is it has to pass through the origin or through the 0, 0 part of the graph. This does not. So let's analyze this. First, the rule that we came up with from that problem doesn't fit this format. Because of that, it can't be proportional. And secondly, the graph of the relationship doesn't pass through the origin. When I graph those points of my x's and my y's on an xy graph, it didn't go through 0, 0. It didn't come up like this. It came up above the origin. So it can't be proportional. So either one of those things means it's not. And remember, you can have a rule that isn't proportional. This is a rule right here. It's just not a proportional rule. One more example. This is the same directions, but the problem's slightly different. It says most shower heads that were manufactured before 1994 use 5 gallons of water per minute. Well, that's a pretty easy rule, where X represents the time in minutes and Y represents the water used in gallons. The total gallons used would be 5 times however many minutes the faucet's being run. or the shower head, excuse me, is being run. Okay, so after 1 minute, it would use up 5 gallons. That makes sense. So 2 would be 10, 3 would be 15. I can easily divide by 5 to get my x here. So 35 divided by 5 is 7, and 10 times 5 is 50. Oh man, that's awesome. Notice right off the bat, I could use division very easily to get from the 35 to the 7. Whenever you can use division real easy like that, you know the relationship's proportional. Okay, now I got to graph my points. 1, 5, all right, 2, 10, 3, 15, and 7, 35, and 10, 50. And let's see if I can connect these a little better this time. Oh, I think it was this one. I think I selected the right one here. Yes. Yay! Selected the right line. Okay, that's great. That's pretty close. Notice, even though we didn't have the point 0, 0 on our table, if you extend that line all the way back to the beginning, it intersects right here at 0, 0. That's interesting. So because for that problem, the rule was y equals 5x, where the constant of proportionality is 5, we know that it's proportional because it fits the format. It fits this format. A is 5. See that? It's red and so is A. The constant of proportionality is 5 here, so it's proportional. Additionally, because the graph passed through the origin and is a straight line, we know it's proportional. So those two factors helped us decide. So, quick recap. I'm going to, on the worksheet, there's a few problems where it just gives you a graph and it asks you, is it proportional? Connect the dots with the line. If it goes through 0, 0 and it's straight, you know it's proportional. There's going to be other instances where I'm going to give you word problems, just like this up here. And I'm going to ask you to complete a table and then make your own graph. Use a ruler when making your graph. I want these lines here for the y-axis and the x-axis. I want those lines to be much straighter than the lines I just tried to draw. I want them to be perfect. So as you go to create your own graphs, you must use a ruler. And be careful of how you scale the x and the y-axis. But I know you're going to do a great job and make beautiful graphs that will make me proud to be your math teacher. Well, I shouldn't say that. I'm already proud to be your math teacher. But will make me even more proud of you. Good luck to you.